Just FYI. And continue. All right, ladies and gentlemen, welcome. Today we are going to be talking about analyzing functions with regression. It will be a calculator day, so try and get your calculator up. I do recommend that you follow along. Let's see. Hi, yay. Okay, so let us begin. The objective is on the board. I'm going to go ahead and write it in. Today, boys and girls, we will identify and write linear, quadratic, and exponential. So we're going to be looking at 3 different types of functions, guys, okay? And exponential functions given data, from given data. Okay. So I think to start off with, let's look at this first example, okay? They're telling us to graph. I'm going to show you a shortcut. Determine whether the ordered pairs are represent a linear, quadratic, or exponential function. Of course, if it's linear, it's probably going to be a straight line, right? If it's quadratic, what's the name of this shape? Don't remember? Parabola. Yeah, everybody wants to say parabola. Nope, just parabola. Not a nice word. Exponential looks something like this, where it's like all of a sudden and it just takes off, right? Or all of a sudden it just drops, right? Something like that. All right, so I'm going to show you a shortcut to make that happen. In your calculator, the first thing we want to do, let's just get it out of the way. Anytime we're entering tables and stuff like that in our calculator, we want to go to mode. And if you want to, you can look at your little click sheet here. Okay. I think the part that talks about doing the mode thing is to turn on stat diagnostics. See that? Okay, well, I'm just going to show you. You hit mode and you go down until you select stat diagnostics. Go to the right. So you're hovering on the word on and hit enter. When you back off from it, you should see the word on with a highlighted background to it, right? So now that we have that, we can enter our table. Well, I don't see a table here, but I do see a bunch of points. So I'm going to go ahead and make an X, a Y, and I'm going to make my own table. 1, 2, 2, 5, 3, 6, 4, 5, and 5, 2. Okay. Does anybody remember what button I need to hit in order to put a table in my calculator? And it is stat. Good job. So right here, this is where we're going to be using this, right? Stat. Okay. And 1 for edit. And everything under L1 is going to be about X. Everything around L2 is going to be about Y. Okay. Go ahead and let you in, madam. Okay. Now let's go back to the table because I need to see it. And I'm going to type in my values for X. 1, enter, 2, enter, 3, enter, 4, enter, 5, enter. So to find that, what you have to do, if I'm in my basic screen, right here, I hit stat 1. And that takes me there. So I put in all my X and I have all my Y's. So I'm going to go right here. And I'm going to enter 2, enter 5, enter 6, enter 5, enter 2. Now, just by the way this data looks, does anybody have any idea what it might be? Parabola. Okay, in the shape of a parabola, but a quadratic, right? Because we have 3 options, okay? So I'm going to go ahead here and according to our little click sheet, once we've done that, they talk about adjusting the window, which is nice. Okay, you can kind of make sure you have everything, and I'm going to blow that off. He gives you some pretty cool stuff. Okay, so like number 1, he tells you we can actually see the dots, right? So you have to go to Y equals. I'm on step 3. Go to Y equals, and then we want to arrow up so that we're blinking and our cursor is on plot 1. Okay, and I'm going to go ahead and hit enter. And then I'm going to go down and make sure, yes, it is highlighted, right? So once I have that, I can actually just hit graph. And there are my little dots. You see them? So were we right about it being a parabola? Were we right about it being a quadratic? Absolutely, okay? So I'm going to go back over here. And based on the graph, and I can just draw a little picture too. It looks something like that, right? So based on that, we know that this is quadratic. I'm going to show you another way where here we have the change in x. Now, in order to do this method, it has to be like, you know, the same right here. You have to have the same. But if you're taking your SAT, you don't have access to a calculator, I want to definitely show you how you can tell from a table. Here, I'm increasing by how much? 2 to 5. 3, right? And then the next time it's just increasing by 1. So I can definitely eliminate linear, right? Linear always had the same thing every single time. Now all of a sudden I'm going down. And I'm going down by 1. And then I'm going to go here. I'm going down by 1 and I'm going down by 3. Okay, so it's not the same, but if I want to verify that it is quadratic, all you have to do is take a second difference. So to go from 3 to 1, I'm subtracting 2, right? And we can do a little number line. All the way from -3 to +3. And again, we were going from 3 down to 1. So that was definitely 1, 2, down by 2, right? And then again, from 1 to -1, and that's down by another 2, right? And from -1 to -3 is down by another 2. Okay, so when the second difference of y is the same, it has to be quadratic. Got it? That's how you can tell from there. Any questions? Okay. And let's go ahead. Next part. All right, let's look at this next one. So here they're telling us to graph these points, determine whether the ordered point pairs represent linear, quadratic, or exponential. All right, so if we graph it, we need to make a table, okay? So I'm gonna go ahead and make a little table here, X and Y. I will tell you there is a trick to entering fractions into the calculator, so I'm gonna show you. We have -1, 0, 1, and 2. I'm just pulling all of the X values, right? And then 6 goes with -1, 2 goes with 0, 2 over 3 goes with the 1, and 2 over 9 goes here. Okay. So if I look at this, I'm going to go to, how do I enter a table again? What button do I have to push to enter a table, not view a table, but to enter a table? Stat and edit. Okay. And Philip thinks it's exponential. Any reason why, sir? You want to share? Because you graphed it. Okay, let's take a look at maybe what he's looking at. 1 and 2, and then delete, right? We don't want that to mess it up. So I'm going to go ahead and go back up here. I'm going to put in 6, enter, 2, enter. Now to put the fraction in, if you hit 2 divided by 3, it gives you a decimal, right? This is not bad, but let's just say that you want to be very, very positive that you put the correct thing in there. The way you have to enter a fraction is that you have to put the numerator in first, and then you select alpha y equals 1, and then you can put in your denominator, and then you get like that. That's how you get a fraction in there. So you got 2, and you got alpha y equals 1, and then you have 9 as your denominator. Enter. So let's look at the graph.
How do you do the fraction thing again?
Oh, okay, let me show you. So back into stat 1. Let me go down here, right? Let's say I want to do 2 over 9. So what you do is you just put your numerator in, and then you have to hit alpha y equal 1. And then you put in 9 as your denominator. And then you can put in your fraction, right? So, you know, it will work if you say 2 divided by 9. That's fine. It will work. But if you do want to see the fraction, just to double check. So we hit graph. And I see something that starts like this, drops really fast, and then kind of gets like that. So I could see where you might think exponential. Yeah. And honestly, -6, I'm just going to do like crazy rough sketch here. You know, something like this, and here we go. Okay. And we're going to pretend that my line connects all the dots. Now, if we're looking at it with strictly a table, guys, okay, and we don't have access to the calculator, this is how you do it. You say right here, we know that we're increasing by 1. So as long as it's the same, we can move on to the next step, right? The next step, you want to ask yourself like, am I subtracting by 4 every time? No. And I could go down this path here, right here, but I'm not. Does anybody see a relationship between 6 and 2, and then 2 to 2/3, and then from 2/3 to 2 over 9? Anybody see it? Don't think adding and subtracting. And it's not an art, so it's not quadratic exactly. If it's kind of like, it's like that. Does anybody see how to consistently, what are we doing every single time? All right. Ladies and gentlemen, exponential, what is unique about exponential is that you're multiplying or dividing by the same thing every single time. So here we divide 6 by 3 in order to get 2. You see that? 2 divided by 3. Let me go ahead and do it like this. Ends up being 2/3. You see that? And then if we take that and we divide that by 3, we get our 2/9. So every single time, so the -4 thing, that didn't work, right? That was no good. But we could totally do this. We could say, hey, guess what? We are going to divide by 3. We're going to divide by 3, and we're going to divide by 3. Another way of saying that we divide by 3 is multiplying by its reciprocal, right? 1 over 3, multiplying by 1/3. So keep that in mind. So because we multiply, or depending on how you look at it, multiply or divide, by the same number, it is exponential. Okay? Let me point out one other thing. On the calculator, guys, you know, we have like a regression, like where we can come up with the equation, right? And I'll show you that on the next one. But for exponential, I really don't trust the calculator. I think it's a little, just a little bit off, all right? And you know what? We didn't do that. So let me back up to example 1 really quick and show you how to come up with the with that. Actually, you know what? I already have. Yeah, let's go here. So real quick, stat 1. I'm going to put in all my values. I've got 1 enter, 2 enter, 3 enter, 4 enter, and 5 enter. I'm going to go to the right, put this all in, 2 enter, 5 enter, 6 enter, 5, and 2. Now to get the equation, we're going to use something called regression. This right here is on this part right here where he showed us how to graph it, right? But step 5 is showing us how to use regression, okay? So essentially what we want to do, once we have our table in, we select stat, calc, and if we think it's linear, we're going to hit 4. If we think it's quadratic, we hit 5. If you think it's exponential, don't use this, okay? So we think it was quadratic. Let's go to 5, calculate. And ladies and gentlemen, so long as r squared is 1, okay, and a is not equal to 0, if you got both of those, then you can use y equals -1x squared plus 6x minus 3, otherwise known as -x squared plus 6x minus 3. So this is one way you can use the calculator to help you write the equation, okay? Now, if we want to do that over here, let me show you how you would do that by hand. Now, today's assignment that you have, because remember, we're getting a jump start on tomorrow's. So today's assignment, you're going to become more familiar with this form, y equals a times b to the power of x. This is exponential because your exponent, your x variable is in the exponent. This right here is your initial amount. Which intercepts represents your initial amount, x or y? The beginning of your story always happens at what intercept? Anybody know? Okay, it is the y-intercept. Good. Okay, so it's the y-intercept. It's right here. That's typically the beginning of your story where x is equal to 0. That's your initial value. So we're going to take that. So a is going to be equal to 2. B is the number that you multiply by every single time. Okay, so here we're multiplying by 1/3. To the power of x. And that's how you write that. Okay. Any questions on this? All right. Let's go to example 2. Yeah, no.
For the answer, like for the 2, like I don't understand that part.
Okay.
Like why you choose that one, why not 1 or -1?
Okay. Anytime we have any kind of word problem, right? Anytime that we talk about the initial amount, basically it's always the y-intercept. Okay. Now, sometimes it can vary depending on the particular case, but in general, and it always just works out. This is our first point. Okay. That's why it's the beginning of your story, the initial amount. Any other questions? Okay. So let's go ahead and let's look at example 2. We want to look for a table, a pattern in the table that best determines the kind of model describes this data. So here, this is increasing by 1. Would y'all agree?
Yeah.
All right. How much is this increasing by? Ladies and gentlemen, what is this? Do you know? Linear, quadratic, or exponential? Thank you. It is linear. It is linear because you have a constant rate of change, right? And because the first difference is the same.
Remember back in the good old days when we only had linear equations?
Tell that to the freshmen next year in September. Like, enjoy it now. All right. So it is linear because the first difference of y is the same. Okay. So right here, this first difference. All right. I don't know why I'm writing that. By the way, okay, be quiet, little thing. Okay. So this right here, this is my change in x, right? And you could definitely use your normal little slope that y'all like, the y2 over y, y2 minus y1 over x2 minus x1. You can definitely still use that, but this right here is your change in y. And if we were wanting to calculate our slope, m is equal to the change in y over the change in x. So that is simply 2 over 1, which reduces down to 2, right? What did we just say about b? The y-intercept, what has to be equal to 0 at b? What's always equal to 0 at b? X. X is equal to 0. So I identify that here. Boom. There's my b, right? So b is going to be equal to 3. Now that I have that, I can write my equation. Y equals 2x plus 3. Ladies and gentlemen, you can still put it into stat. 1. You can just get rid of everything. I definitely don't recommend using the clear button when you're in stat. You can kind of cause some damage. So just be patient and use the delete one at a time. And then let's just put it in. I got my -2, my -1, my 0, my 1, my 2, to the right, -1, 1, 3, 5, and 7. And then I'm going to go to, I could actually graph it and look and see what does it look like. Looks like a straight line, right? It's linear. If I want to get the equation, I hit stat, calc, and which option looks best, 4 or 5 for linear? 4, because it starts with LIN, right? And then we just calculate. Ladies and gentlemen, so long as R squared is equal to 1, then we can move on and we can say, hey, there it is, y equals 2x plus 3. We got it. We checked it. We verified it. It is correct. By the way, just a little something, little star review kind of thing. This R equaling 1, that's my correlation coefficient. Going back to the days of scatter plots. What does it mean if you have a correlation coefficient of 1 or close to 1? Ooh. So I think y'all should research that today and bring that as a question for me tomorrow if you do not know, because that will be on your test. Let's look at example 2b. We're going to look at this pattern. Everybody okay with this one right here, this linear example? Cool. We're looking at this one right here. Again, we're just going up by 1. Life is good, super easy. Let's look at the bottom. Ooh, what are your thoughts? What do you think the pattern is?
Divide by 3.
I love that. Thank you. We're dividing by 3, right? Or we're multiplying by 1/3. Beautiful, guys. Okay. So now if I was going to write my equation, y equals a times b to the power of x, okay? And that's our initial, otherwise known as our y-intercept, right? And this is what we're multiplying it by. What is my value for a going to be? Anyone? 4, good. Because x is equal to 0 at the y-intercept, right? So I know that I've got y equals 4 times what I'm multiplying it by to the power of x. That's all we have time for, boys and girls. Have a beautiful day. Not be on there. Okay, and I'm going to hit this, continue. All right, let's look at this one. Determine the kind of model best describes the data, then write on the equation for the function that models the data. This is going up by 1. That seems to be a trend. And then right here, multiplying by, because it looks too big, right? We're multiplying by what? 8. And if you're ever in a situation where you can't really figure it out, you just take that second number and you divide it by the first number, right? So for example, here I could take, let me just get out of here. I could take -4,096 and divide it by -512, and I get 8. So I know I'm really multiplying by 8 every single time, right? Now, let's go ahead. Since we're multiplying by the same thing every single time, we know what kind of function is this? Nope, linear is when we add the same thing every single time. So it's not linear. The second difference, it's got to be quadratic. Okay, so linear is if you're adding the same thing, right? Quadratic is if your second difference is the same every single time. So still adding and subtracting. This one is exponential. Exponential is when you are multiplying or dividing by the same thing every single time, right?
Wait, is quadratic adding to like linear?
The second, yeah, this is adding and subtracting. This is adding and subtracting. And exponential is all about multiplying or dividing by the same number every time. Okay, so we have enough information to write our equation, right? We got y equals a times b to the power of x. What's our initial value? What's our y-intercept? -1 right here. X is equal to 0, therefore this is b. So I'm going to put -1. Inside the parentheses, that's what I'm multiplying by. That's 8 to the power of x. And we're done. Any questions on that?
So it's basically the X value is going where A is and the Y value is going where B is.
The X value is going where A is.
So like since it's +1, it'll be 1. Never mind.
No, this is the number that we multiply by. I'm sorry, this is the initial, my bad. The initial value, the y-intercept, and this right here is the number that we multiply by every single time, right? All right, this last one, I'm gonna go ahead and pause the video. Okay, example 4. So here we have a karate problem, a word problem, and it's about karate. So the table shows the number of children enrolled in a beginner's karate class for 4 consecutive years. Determine which model best represents the data, and then write a function that models the data. Okay, the first thing that you have to do with word problems is you have to decide which one is going to be your independent and which one is going to be your dependent, right? And so if you remember Dixie Royd, independent is right here, okay? Independent, kind of squeeze it in, okay? And dependent is right here. And so we can remember, hey, y is, we feel like it's dependent, then it's going to be the y. And if we feel like that's our independent one, then that's going to be x. So when you ask like, okay, which one am I going to write down first? What comes first? What do I need to know first? And so am I going to look at the number enrolled or am I going to look at the time in years? Well, time is going to be what we want to know first, and then we record the number enrolled after that. So this is your x, it's independent, and this is your y. Now that we know that, what we can do is we could actually kind of look at it. Sometimes you can get a look at it and feel, a feel for it and see like, well, you know what? Are we adding the same thing every single time? And it does. It appears that we are absolutely adding 3 every single time. Here we're adding 1 every single time. So this is our change in x and this is our change in y. So when the first difference in y is the same, we know it's got to be linear. Okay, I know that my slope, m, is going to be the change in y over the change in x. And so that is 3 over 1, which reduces down to 3. And I know that my y-intercept, let's see if it'll work for me. No, it won't work. My y-intercept is where x is equal to 0, right? So here's x being equal to 0, and it's on here, right? So that is my value for b. B is equal to 8. And I can write my equation, y equals 3x plus 8. Now to entirely verify it in my calculator, I want to go ahead and go to stat 1. I'm going to clear all this stuff out. Delete, 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 delete. Okay. And let's go ahead and put in this in 1, 0, 1, 2, 3, 4. So 0, enter, 1, enter, 2, enter, 3, enter, 4, enter, right? Let's go to the right. Let's put in all those numbers. 8 and 11, 14, 17, 20. And now that we have it in, we can graph it. And I might need to zoom out, zoom 3 to see it. Okay, I can kind of see it. Sometimes graphs are helpful and sometimes not really. Let's go ahead though, but we got a good idea that it is linear, okay? And let's go to our actual stat. We come up with the calculator with the actual regression. So since we suspect that it's linear because the first difference is the same, we can select 4, enter, enter, enter. And so long as r squared is equal to 1, then we know all the points land really close to this line, this equation, right? It's right on there. So provided that r squared is equal to 1, we can move forward and we can say y is going to equal 3x plus 8, which guess what? That matched exactly what we came up with. So we know 100% that we're going to get that correct. All right, ladies and gentlemen, that's the end of our lesson today, analyzing functions with regression, and I will see you tomorrow. Take care.